Hello everyone, welcome to my session exploring cloud intelligence, leveraging Prestos for data analytics on AWS Cloud. My name is Henry Clavel and I've been working in the field of data for 10 years, utilizing open source tools and cloud technologies to help the client with their data management and enterprise system. I'm excited to talk to you about this project and share how I leverage Presto as an opportunity to improve performance in the data architecture and optimize query results using this engine. I'll also discuss the hybrid cloud solutions implementation that move data from on-prem to the cloud, utilizing Athena as our starting point to query data in a data lake and perform unit testing, regression testing, and end-to-end testing. We'll also explore the key differences between Presto and AWS Athena. We will delve into the deployment and management requirements and performance capabilities and the customization options that come when using Presto. The focus will be on understanding how Presto can be effectively leveraged for data analytics in AWS cloud environment, particularly in the hybrid cloud solutions. Highlight scenarios where each tool excels and provide a comprehensive performance and cost comparisons through sample queries. I will also talk about the hybrid cloud implementations, moving data from on-prem to the cloud, using intermediate state, and leveraging the AWS suite to move data to the data lake in S3. By the end of this presentation, you will have an insight needed to make informed decisions for your data querying needs in hybrid cloud environments. In this past project, the primary goal was to transition data from on-premises to the cloud effectively. We faced the challenge of not only moving data, but also establishing a robust process and comprehensive testing phase once the data was transferred. We dedicated a few months to thoroughly understanding the data in its source. This involved converting data from its original format to a suitable file type, and testing this file through various stages of the migration process, from the initial stage to an intermediate stage. Modernizing the data architecture from on-premises to the cloud required a deep understanding of the limitations of the old system while leveraging the capabilities of advanced tools of AWS to process large volumes of data. The objective was to build a self-service tools for users to query data in the cloud. By implementing a hybrid cloud solutions, we managed to use the latest technology offered by AWS, but we also had to maintain the existing on-premises systems and servers without disrupting other applications. This approach helped us to integrate the new cloud capabilities while ensuring the operations of the old system. The hybrid cloud option provided a significant advantage. The client and their users could leverage the AWS cloud tools such as AWS Sync, Glue, and Glue Catalog to build applications up top of the cloud environment. This also opened up an opportunity to use other advanced tools for future projects to enhance the user experience. To ensure the proper transition, I developed a detailed process and outlined 4 initial data sets, along with a timeline to deliver the results to the client. These data sets were prioritized based on their importance and complexity, forming the foundation for the cloud project. The roadmap I outlined included initial assessments, the data conversion, the testing phases, user enablement, and continuous improvement. The initial assessment is understanding the data and defining the conversion methods. And the data conversion, transforming the data from the source format to the cloud. The testing phases, this is where I work with the testing team to set up a plan and implement the solutions. It would be stage 1 and stage 2 would be the initial transfer and the intermediate validation. And then user enablement, creating self-service tools to empower users to manage and utilize the data effectively. And continuous improvements, essentially iterating and enhancing the process based on the feedback and the tools or technical debt that results in the implementation of this tool. In this use case, Our objective was to move 4 datasets from on-prem to intermediate stage, specifically file storage. By partitioning the data on a daily basis, each day we will create a file and from the partitioned data and copy it to intermediate stage for review. The data process ensured a consistent and manageable flow of data from source to intermediate. To provide a little background on this process, the data was housed in a Hadoop environment, which needed a specialized tool to effectively query and manage the data in staging and in production. When establishing a staging environment, we could process and create test files. We focused on testing sample datasets before engaging with data that contain PII or personally identify information and other sensitive information that comes with it. This required to mask sensitive data and create another secure location to ensure the protection of the data. So we would have the main data sets, and then we'll have additional tables created that contain non-PII information, which added another layer of data validation. And this added complexity extended the time needed to validate the process from the data from stage 1 to stage 2 of the hybrid cloud solution. It involved multiple steps to ensure data integrity and security was closely monitored and tested and approved. Working closely with the testing team, we implemented several crucial steps in the process. We need to check and review the data for any corruptions during the transformation stage. This involved rigorous unit testing to ensure accuracy and integrity of the data was transformed and stored properly in the file storage. We also performed data reviews by downloading the files and comparing them with initial on-premises data, and also using the querying tools to verify the results from on-prem with a file. There is a breakdown of how we perform these processes from on-prem to the cloud. Data partitioning and file creation, staging environment setup, data masking and security, transformation validation, comparative analysis, and collaboration with the testing team. By following this meticulous process, we're able to migrate the data from on-prem to intermediate stage, ensuring that data and security and compliance were up to standard. This project demonstrated the complexity involved in data migration, but also highlighted the importance of thorough testing and validation to achieve a seamless transitions to the cloud. So we're able to use AWS. We're able to use the benefits of AWS Cloud Sync, AWS Glue, AWS Data Catalog, and AWS S3 buckets. When testing was completed and the data was moved from stage 2 to stage 3, we had to automate the process of moving data from file storage to S3 bucket using AWS Sync. To do this, we had to set up and configure the network within the stage environment to handle any data that was dropped, copied, and processed to raw layers of the bucket. We developed a glue job to detect when a file lands in the staging area, manipulate it by changing the field name from timestamp to AWS timestamp, and execute this change using a step function. This function will trigger the job, and upon completion, an email will be sent to the admin account to confirm whether the job was successful or it had failed. Once the glue job processed the data, the new file was copied over and curated bucket in the data lake. By leveraging Amazon Athena, the data lake was then ready to be queried and reviewed. The Glue data catalog was set up and developed from the initial stages of the environment through Terraform. Instead of discovering or adding the schema in the AWS tool, it was already created and ready to perform when the data would land in the curated bucket. This was possible when the fields and schemas were created within the resources of Terraform in the staging and production environment. The data would land in the raw bucket and it was prepared to query and create later of the data lake for the users. Using these serverless tools, we create an environment that allowed us to automate and process partition data efficiently. However, as volume of data continued to grow on a consistent basis, we face instances where the data would fail to process or copy correctly. We encountered downtimes and timeouts when querying the data within the Amazon Athena suite. Although these issues were documented, we knew they were restricted by the limitations of the AWS tool. To address these challenges, I would explore using Presto, which has proven successful in the IBM's watsonx project, to provide a scalable and optimized way to query data from the data lake. This alternative way to query data through a server would help make our process more robust and enable faster data query as the volume data in the environment continues to grow with new implementations on the horizon. Using Presto enables us to create a scalable environment that isn't restricted by the AWS services that we're using. Presto's distributed system allows us to query the data lake without worrying about timeouts or slowness as more data is consumed and processed on a daily basis. To work on the solution, we needed to understand how Presto works and how to integrate into our environment. By researching, we set up Presto using the EC2 instances. We have to remember that why we're using and installing Presto's distributed system and why it benefits the hybrid cloud project. By setting up an EC2 instance, we create a node that helps us scale and process queries. For this setup, we didn't use the free tier of the AWS services. Instead, I opted for the Amazon Linux to AMI. The instance type we chose was a T3A medium, which is a good start to balance compute, memory, and network resources. For storage, I would use 8 gigabytes to get started for the general purpose SSD for the EBS. This configuration supports both the installation and the query of data within the AWS environment. By following these steps, we successfully established a Presto environment on AWS. This setup allowed us to leverage Presto's capability to efficiently query our data lake. The performance improvements and scalability offered by Presto address many of the limitations we face with other tools. To be able to handle large data sets and more complex queries without timeouts or slowness. Our experience with Presto optimized our data querying process, but also provide insights into the potential of distributed query engines for big data environments. Moving forward, integrating Presto into our workflow will significantly enhance our ability to manage and analyze more data sets that will come our way. But how? So we would enhance the Presto cluster. To fully utilize Presto's capabilities, we need to set up additional nodes to share their workload. A Presto cluster requires a master and worker nodes to distribute the scheduling and monitoring of query execution. To improve the Presto cluster, we set up additional EC2 instances using the same Amazon Linux environment. So for a simple setup, we need a master and worker nodes. The master node handles the scheduling and coordination of queries, while worker nodes execute these queries. So to get Presto up and running, we need to set up a Java development kit within the Amazon AMI. So we would install the Presto as the JDK on the OS, as Presto requires Java for installations. And also, once you SSH within that service, you install the Presto binaries. But the most important part of that setup is the config properties, because we need to outline within that config file that the first master will be the coordinator. So we set that as true. This that designates that this is the master, and it will not handle any data processing tasks. So we also need to indicate within the config that the coordinator is false, and we need to set the port of the HTTP server as well. Also provide the minimum and maximum memory that can be used within this cluster. And also make sure that this AMI or computer or master can be discovered later by other worker nodes so it can be utilized. And also develop a coordinator HTTP setup. By setting up these parameters in the config property files within the EC2 instance, the Presto cluster efficiently manages resources and handles queries. After configuring these settings, we should see a web UI and the HTTP address to monitor the engine. This setup establishes the master node, but we also need the worker nodes for Presto to function properly. And it's the same setup. The only difference is that the config property will need to indicate that the master needs to tell the file that this will only handle data processing tasks, and it's not the coordinator or the master. This designates the node as a worker. Once this is set up, we start the daemon, or like the previous settings, it will be activated, and it will appear within the image here that a worker node is active. You will see additional worker nodes can be set up similarly to be optimized and improve the improvements of the Presto engine. By following these steps, we create a robust and scalable Presto environment capable of handling our growing data needs. Within this section, I wanted to highlight the difference between AWS Athena and Presto. As I described previously, Presto set up an EC2 instance and requires manual and additional multi-node clustering, and it's infrastructure based, versus what Athena offers, which is limited. It's fully managed by AWS, and you pay per query, and it's primarily used on AWS S3. But with Presto, we have more options and more opportunities to query data from different sources once we have additional data sets loaded into our environment. And it's best for large-scale frequent query usage, which will be useful for our users once they get onboarded into respective groups within the security and be able to utilize the services. To recap, what we started within our presentation talking about the implementation of a hybrid cloud solutions from on-prem to the cloud, scaling that process and using Presto, and setting up the worker nodes and master in order for the Presto binaries that can be utilized fully. By understanding how the difference between Presto and Athena is used, we can leverage the open source system to build more robust queries and scalable architecture without the limitations and the serverless options that AWS offers. With that, we're confident that users will be onboarded and there will be no disruptions in their user experience for self-service and the ability to collaborate with other data scientists, data engineers who want to utilize the data in our setup. So I would like to thank the organizers for this invitation, and I'm excited to be part of this event. If you need to reach me, I can be reached in my email and my LinkedIn listed here. Thank you so much. Have a good evening. Bye.